Okay, today we're going to learn a little bit about glide and like TXVs and superheat and how it affects it and blah, 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 blah. So anyway, so first off, let's say we're going to start off with a refrigerant like R22. Good old R22, right? So this is the evap coil. We have temperature 1, which is at the beginning of the evap coil. And let's say at 10 psi, that theoretical temperature is -20 per our PT chart. So we're going to have T equals -20. T1 equals -20, all right? Now at the other side, let's say if we're targeting like 3 to 6 degrees of superheat, we're going to have T2, and that's going to be after all our refrigerant goes through the coil and everything. And then the temperature number 2, let's say, is going to be 25 degrees. Sorry, not 25 degrees, negative 15, okay? So what does that mean? Well, it has increased in temperature 5 degrees from point 1 to point 2, from the beginning of the coil to the end of the coil, by 5 degrees. So that's 5 degrees of superheat. So superheat, SH, will equal 5 degrees. Okay, and that's it. And so, like, what does that mean? What is that? Well, a lot of the times, kind of what you're doing with superheat is the engineers or whoever designed it kind of says, well, if you have about 5 degrees of warming up this kind of refrigerant, by the end of our coil, just about all of it's going to be evaporated. So you're going to have a nice vapor that goes back to your compressors. Also, it matters for efficiency, as in if you stay in this 5 degree superheat or whatever your manufacturer says works with your evap coil or your system, it's going to be more efficient and you're going to get the most out of your refrigerant. Now, what happens to superheat when it comes into contact with glide? And what is glide? What is it? I don't know. It's something, right? So now we're going to have the same coil, but with 448 or R22 replacement, right? So we have temperature 1, which is, let's just say, our temperature 1, our theoretical temperature 1 is -20. Right, and this is just a scenario that I ran into the other day, and I want to show it. Let's just say, our theoretical temperature 1 is -20, and then temperature 2, let's just say, is -30. Well, how is that? How in good gobbledygook town is that even possible? Like, how do you do that? Right? Did we lose heat? Like, you can't lose heat, right? Going in a room like absorb, you can't lose it. So how did that occur? Right? How does that happen? That doesn't make any sense at all. Well, it's because refrigerant 448 is a refrigerant mixture. Okay, where R22 is a compound. That means if you had, a cylinder filled with R22 molecules, okay, and you were to pick any of these molecules, you would always get R22. It's just the type of molecule of something. Some chemist somewhere came up with this molecule. Now, if you were to do that with 448 over here, let's say, and you were to pick up a random molecule, you're actually going to get random types of refrigerant that are mixed together to make 448. So if you actually look up 448, it's made of 32, 125, 123.4 YF, 134A, 123.4 ZE, right? And it's made up of 26% of R32, 26% of R125. And if you look at, right, and all of that all together in those percentages mixed together like salad dressing gets you 448. So if you were to reach into this and just grab a random molecule, you would actually get like R32 or maybe R25 or maybe R whatever, because it's a mixture, right? And every bit of that mixture, each one of those individual components has a different temperature associated with the pressure, right? So for instance, at 10 psi, if we were to look up the pressure temperature chart for refrigerant 448, it's going to tell you that you have about -20 at 10 degrees, right? You're -20 at 10 degrees for R448A. And then you're like, oh, that's cool. But then you look on the other side and you go, it's -30. That doesn't make sense with my good old R22. That never happened, right? Why? Is because if you look it up, over 50% of this refrigerant is made up of refrigerants that boiling points at 10 psi are below the average of all the refrigerants together. So what they do is they'll average the refrigerants all together based on their proportion of what they make up, and then they come up with this -20 value over there. It's an average of the refrigerant blend. And so glide is your variability between those averages, okay? And it also has to do with how things will condense down. If they boil off at different temperatures or evaporate at different temperatures in the evaporator, they will boil off, they will condense down at different temperatures in the condenser as well. So when you're on the floor and you realize, I'm reading a negative superheat, think about the kind of refrigerant that you're dealing with, right? Because I'm losing 10 degrees across this coil. And you might think to yourself, well, I guess my brazes are broken. My gauges are broken. I trusted Gendron HVAC-R. He said get the test those, and they crapped the bed on me. Oh boy. And then you realize I'm dealing with 448A. And over half of that refrigerant has an evaporating point that's below what the average of it is. So if you're overfeeding a coil, like you're flooding out a coil, it's very possible to have a superheat that's colder on the other side when you're dealing with a refrigerant blend. And so just a quick reviewer here. So glide is the variability in the different kinds of refrigerants. So this refrigerant's going to evaporate at this temperature, this refrigerant's going to evaporate at this temperature, this one evaporates at this one, and that one, and this one. And it's the variability and how that affects your system, of how it evaporates or boils off, and then how it condenses down in a condenser. But that is how your glide will affect your superheat. And so do not be shocked or taken back if you go to a system that's overfeeding and you have a negative superheat if it's made with one of these refrigerant blends. Just wanted to mention, you go onto the Google, right, on the interwebs, and you type in, refrigerant 444A, and you just go to Natural Refrigerants Inc., right, or the refrigerant manufacturer that you're in question, right, and you look at the can that they have there, and you can see right there it has R32, 125, 123, 134, 134, 123ZE, right, and it has all the different kinds of refrigerants, and then underneath it, right there, it has the proportions that is there. So 26%, 26%, 20%, 21%, 7%, right? And it's just all right there. And then you can download from this website, their product information, and it'll have more on like retrofits and how to do that. But anyway, maybe you learned something today. I don't know, whatever. Please like, subscribe, hit the bell, hit the subscribe, do all that good stuff, whatever you want to do, whatever. That's how you do it, and so that's just how glide affects your superheat.